Okay, so let's talk about, yesterday we talked about how we do a approximation, correct? Whatever rectangles I draw here is the upper rectangle. So I say as n approaches infinity. So that is how we relate to the sum of the upper rectangles or the lower rectangles as the definite integral here. So as n tends toward infinity, that means the number of rectangles tend to infinity. The width of the rectangle tends towards 0. Am I right? Okay, so the sum of area of infinite numbers of rectangles will approach the exact value of the area. You see, I use the word bounded. So there are how many boundary? 1, 2, 3, 4 boundary. The curve, this is the first one. The first boundary here. If I redraw the graph. So this is the first boundary. The second boundary is the straight line x equal to a. And another straight line x equal to b. And the x-axis. This is the fourth one here. Since x-axis, I draw it in blue, the x-axis. Oh. And the x-axis. This is the fourth one. So you see, therefore I got this area. So definite integral, if I ask you what is the meaning of this, you must mention this. If I ask you to interpret that, interpret this, so you have to say that is the area bounded by the curve, straight lines, x equal to a, x equal to b, and the x-axis. So that is the interpret, the meaning of definite integral. Definite integral means you know the limit. Do you get me? Hello, class? Okay, so that is how the approximation become the exact. So based on this understanding, based on this, what happened? Do you know why? Do you know why? You want to know why? I shouldn't touch this part. Come back. Okay, I better go away from here. I touch the other button. Okay. So based on this understanding, may I know? Okay, can you tell me what is the value of, if I have something like that? I ask you, what is the value of this? Can you see? Can you see what is the value of this definite integral? What is the value of this definite integral? What do you think? What is the value of this definite integral? If I want to walk to you, I must wear mask. Okay, let's hear from those online. Okay. Let's hear from those online. Yeah. Carol Rampa.
Yes,
Yes,
miss.
young man.
Yes, hello.
Who are you? Huh? Yeah, why so late? Carol Rampa, what is the answer for this
Sorry?
question?
For this, the integer,
For this, yes.
answer is 4. So I got
The answer is what?
4.
4. Okay, may
Yeah.
I know how you get 4?
You
If
say
I have
integer,
this,
right?
I integrate this, correct? That means I have this graph y equal to fx. I have only one straight line, that is x equal to a. So may I know what is the area of this straight line? May I know what is the area of this straight line? What is
is
the
it still
area of
me?
a straight line?
Hello?
Straight line got area or not?
No.
No area. Straight line is one dimension. So the answer for this one is 0. Correct? So based on the understanding of A to A, so it represents area. Straight line got area or not? No. One dimension without area. Yeah, 2 dimension got length, got area because it covers a space. 3 dimension got length, got total surface area, and also got volume. What do you mean by volume? What do you mean by volume? Just now I told you the meaning of area is cover, space, space, correct? Cover. Volume? What English word will you use to describe volume? What word? So in this case, we are not, for integration, we are not going to cover volume. For Form 5 high school, you got talk about volume, correct? Because you talk about space, a space turn around 360 degrees. Right? So this one we are not going to. So what do you mean by volume? Do you have volume? Do you take up space? So another word of take up space, say what? What is it? Or occupy. You occupy a space, so that is your volume. Air got volume or not? Got. Air got volume or not? Air don't occupy space. Does air occupy space? Yes. Air occupy the whole space, whatever the space of the container. Okay, so this is what the meaning of definite integral. All right. So remember summation. Okay. Now I'm going to give you another one that you have to bear in mind so that when we discuss about area bounded by the curve in chapter under application, you will know what to do. Okay, so another one is, did I record? Yeah, I did. So now I'm going to stop recording. So depend on where is the location of the area. Yes, young man. Are you writing? Sure, finish writing already. You have to. Then only you can remember. Correct? So there's one, this is one way of writing it. So there is also another way of writing it. So do you know what is another way of writing it? Have you ever seen this one? 2 lines? Whenever I write something 2 lines here, what do you mean? Anyone in the class? Can you tell me what is the meaning of these 2 straight lines? Modulus. If you say modulus, it doesn't give you the idea how to get the value. Always positive, so we call it absolute value. Absolute value. That means I don't care about the sign. If I say absolute value of -2 is 2. Absolute of value of 2 also is 2. That is the meaning, absolute value. So in your graphic calculator, you will see this as well. And I also can have another way of writing it. So we will talk about it when we come to the integration rule. Right? So there are two things that I want you to bear in mind today. That is this one. That is this one. Understand? You see, the upper limit and the lower limits have the same value. So it's a straight line. So the definite integral, you are talking about area bounded by a curve. So area bounded by a straight line, there is no area. So answer is 0. Second thing I want you to take notes of is this one. You have to be careful whether the area is above the x-axis or below. If it's below the x-axis, I ask you to find the area. You either put in a negative sign or you put in the absolute value. Because if the area is below the x-axis, when you integrate, it will give you a negative value. So negative times negative will give us positive. Why we have to put it positive? Because area is a scalar quantity. Are you clear? Scalar quantity is always positive value. Got it? Okay, good. Any question? No question. I'm going to set a question which is exactly like your, going to be like your SAT 3. This one will come out in your SAT 3, one of the questions. Okay, shall we? And you start to take out your graphic calculator and do it. Okay, record. Okay, so we are going to do this. So whenever I give you a question, you should read the whole question. So when you do a sketch of part A, you make sure you sketch it in such a way that is quite accurate. Do you get me? In such a way that is quite accurate. Where is my, okay, thanks here. Okay, in such a way it's quite accurate. So I will do, set the domain and do a zoom fit. Okay, so when I sketch, because from here, the limit is from 1 to 4. So I just now test when x equal to 1, my y is 1.71. When x equal to 4, my y is 3.16. When x equal to 2, my y is 1.34. And when x equal to 3, my y is 1.89. So, and I have the turning point. Oh, my turning point goes 1.6 something, correct? I do again. So all these are the points that you have to find so that you can give a quite an accurate sketch so that you can do your part B and part C easily. So this is my 1. No, my graph not nice. Okay, I try to be as accurate as possible. Huh? So this is my 1, this is my 2, then you go up like that. And here is my 3, and here is my 4. So when I do the sketching, I also prepare for the other one. Okay, so this is a graph, and because I don't want to disturb my graph, so I point this at point A. So I say point A, the coordinates is 1.68, 1.69, and 1.30531, right? Okay, good. So I'm done with part A. If you want to put the two endpoints, go ahead. Okay, in this case, what is important is the shape of the graph. So that is your X. Okay, so then part B. So since on the graph in A, so I have to draw in A. Draw 3 upper rectangles of equal width to find the overestimate of that. Okay, so now the most important thing is you must know every time when you do all this, what must you calculate first? You must calculate the width. Still remember how to calculate the width? The upper limit. This is called the upper limit. Take away the lower limit. Divide by the number of rectangles. Right? Then I got the width is 3. So that's why I mark down 1, 2, 3, 4. Am I right? The width is 1. Don't look at me like that. I'm wrong. Please let me know. The width is 1 unit. Am I right? She got a shock. You send your teacher back to primary school, okay? Okay, 3 units. Okay, so it's 1 unit. So now you look. For the first one, okay, just now I try Y11. Okay, and I have, so if you look at the graph, okay, the first upper rectangle, I should use Y11 because the height of when X equal to 1 is greater than X equal to 2. Am I right? So I draw my first upper rectangle. I use red here, but in exam, please don't use red. So this is the height. So I draw across. So this is my first upper rectangle. I purposely make a mark here. That means I'm going to use the height as Y11. Am I right? Then for the second rectangle, between Y12 and Y13, the height here is bigger. All right? So the second upper rectangle will be here. Do you get me? So it's not a matter of left or right, please. Okay, then the third one is here. You use this point. Draw the whole thing. Use different color. Shade the area. All right? So what we need to do is, whenever we do this calculation, we tell the examiner that our fx is equal to y, x. Understand? So therefore, the overestimate or the sum of all the upper rectangle will be equal to the width, which is 1 unit, times by the sum of all the height, because all the rectangle has equal width. Yes, young man, your hand must move. Move. Okay, so the first one, what should I write? The first one, what should I write? Am I going to write down the value or am I going to use my graphic calculator? I'm going to just write down y11 plus y13 plus y14. Then I'm going to key in my calculator straight away and give the final answer. Are you clear? I'm not going to write down the number and add one by one. So what is the answer? $6.78, is it? Is it 6.78? Okay, good. Everyone know how to do. You don't know how to do, huh? Okay, good. 6.78. Unit square. So we have to be very careful in this case. If the graph changes its direction, so your choice of the height, you have to be very careful. Understand? Okay. Shall we go to the next one? Yeah. Okay, next one is for the sake of explanation that I will draw the graph and explain. Okay, I have. So now let's get the width first. The width will be 4 minus 1 divided by how many rectangles? 6 rectangles. So each rectangle, the width will be 0.5. Am I right? If you read the question, part C. Okay? Okay. Good. So now let's talk about, so the width is 0.5. So from just now we know that our turning point is, what is our turning point? Yeah, so the important is the x-axis, 1.69. Okay, so from 1, hold on. Let me redo. Okay, 1 is here. 1.5 is here. 2 is here. Okay. 2.5 is here. 3 is here. 3.5 is here. And 4 is here. Correct? So now I want to ask you the question. Between 1.5 and 2, the lowest point is, because we want to talk about underestimate, correct? The lower point is at where? The lowest point is at where? 1.5 or 2 or some other place. This is a local minimum, correct? So the lowest point is as 1.69. So when we draw the second lower rectangles, you are supposed to use this point. Do you get me? When the rectangles in between involve either the lowest point or the highest point, then you have to be very careful. So this is the second rectangle. Because we don't know what is the difference between these two areas, so we take the lowest point. So for the first rectangle, we are going to use this point because this is lower. Am I right? So this is my first rectangle. And my second rectangle, I use this point, the lowest point. And the third rectangle, use this point. Fourth rectangle, use this point. Fifth rectangle, use 3. Sixth rectangle, use 3.5. Now you know how to choose. So therefore, the underestimate of this one using 6 rectangles of equal width will be equal to, the width is 0.5. Then the first rectangle, the height is y1, 1.5. The second rectangle is y1, 1.69. Understand? The lowest point. Plus the third rectangle is y12 and go on. So you just key into the calculator. So you get the answer. Got it? So in this question, I'm trying to let you know. Turning point, if the range given involves turning point, please find the coordinates of the turning point. Yeah? If the curve changes its direction, please take note of the selection of the height of the upper or lower rectangles. Are you clear? Okay, so there are 2 things that is I want to get across. So I don't have to give 3 examples. I just need to give 1 example to let you know what are the things you have to take notes of. Understand? So when you learn maths, example don't have to be many. Example, 1 example is good enough. Comprehensive example. Okay, so what is the answer? Yes, young man over there, what is the answer? Anyone. 4.92 unit square. All right? Okay? Dana? Okay. So let's go to part D. Can I? Am I too fast? Okay, let's go to part D. So for part D, the way we answer part D is this. Anyone want to try? How to make a better approximation for this? Anyone want to try? No one. Okay, so I will give you. So very important. So you have to say the limit. within this limit. Okay. Draw, use more rectangles or draw more rectangles, up to you, or equal width. So any of this component is missing, you get 0 mark. This part only 1 mark. If you don't have the limit, then what are you trying to draw? Ask me to draw more rectangles. For which limit? You didn't say. So you don't deserve the 1 mark. And when you say more rectangles is understood. If you want to give an example of the number of rectangles, up to you. For part C, I use 6 rectangles. You can say 10 rectangles if you want to. If you don't mention, it doesn't matter. And equal width. If you don't mention equal width, that won't give a better approximation. Do you know why? Why must I mention equal width? Every question I have to mention equal width. Because if for this case, if I need mention equal width, right? I can use 10 rectangles. From 1, I draw 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10 rectangles. Will that give a better approximation? Definitely not. Am I right? So the word equal width is very important. If you don't mention equal width, I will not give you 1 mark. And it won't give you a better approximation. That's why when you describe to someone to draw certain thing, you have to be very specific. Do you get me? Okay. So this will be one question in your SAT. Yeah, you can go to Times. I got upload some of the question for you to try. You may want to try, or you can go to your textbook. Do you know which page? Which chapter, by the way? Chapter 4, the first exercise. So if you see those questions, we've asked you to find the sum of the area of 20 rectangles, 100 rectangles, all that question you don't have to do. Understand? That's all. So tomorrow we will go into the next part, that is antiderivative. All right? Okay, so I will see you tomorrow. Yeah. Where is the lecture theater? 18. 18 also, I know what to do already. I learned the way to do. Straight from here. You want to learn? You also can do that. You also can do that. Very easy. You can do that also. Okay.